In this video, we're going to talk about final two examples, finding limits using the L'Hopital's rule. So the first example will be um, the limit as x approaches 0 from the right, and 1 over square root of x minus square root of x over x square root of x plus 1, right? And here, notice that you can rewrite this as 1 over square root of x minus square root of x over square root of x plus 1. That's the equivalent, right? And then you can create a single fraction combining these two fractions with the LCD, and the LCD is going to be square root of x times x plus 1, which is x squared plus x, right? That's the LCD. So we can rewrite this as square root of x plus 1, right? Minus x, right? Because x square root of x times square root of x is just x divided by square root of x squared plus x. Okay? And now this can be actually directly evaluated because we will have 0 plus 1 minus 0 over 0 plus 0, right? And it's going to be good because we'll have it 1 on the top and 0 on the bottom, so it's going to be infinity. Okay? Now the second example, the final example, is going to be from the limit from x as x approaches 0 from the right. The function is 1 over x to the x power. So as in the previous video, since we have x to the power as x, notice that if you try to evaluate this at the 0, you will get 1 over 0, which is infinity to the 0th power, right? That's the indeterminate form, right? So you must treat this function as a y value, like this, 1 over x to the x power. Then the ln y will have this, 1 over x to the x power, which can be written as x ln of 1 over x, right? That's the ln y. So now we're going to use the limit. We're going to find the limit as x approaches 0 from the right of this, of the ln y, right? Of ln y, which is going to be x ln of 1 over x. And one more time, if you try to evaluate it as it is, you will have an indeterminate form because there will be 0, 1 over 0 is infinity, ln of infinity is infinity, so you will get 0 times the infinity. That's in indeterminate form, right? So we're going to have to write the limit as ln of 1 over x divided by 1 over x, right? Because that makes sense. That's the equivalent. Okay, and then well, if you try to evaluate it here, you will also fail because in ln of infinity, you will get infinity here. Ln of infinity is infinity, and 1 of infinity is 1 over 0 is infinity as well, right? So you will get infinity over infinity. That's an indeterminate form, right? So you have to use the L'Hopital's rule. You have no choice. So you're going to take the derivative of ln of 1 over x with respect to x and divide it by the derivative of 1 over x with respect to x, right? So that's going to give us the derivative of ln is 1 over x multiplied by the derivative of the inside, which is minus 1 over x squared, divided by the derivative of the bottom, which is minus 1 over x squared. So these two guys cancel out. So you will have the remaining 1 over x, right? And 1 over x, you can evaluate the 0. It will give you, well, let's see. Oh, sorry, not 1 over infinity, 1 over 0, right? 1 over 0 will give you infinity. Actually, did I make a mistake here? Just see something. Negative 1 over x squared. Oh, I made a mistake. Okay, I see what the mistake was. The mistake was I should have set 1 over 1 over x. You see? That's the trouble. Okay? 1 over 1 over x, right? Because derivative of the ln is 1 over what's inside. So 1 over 1 over x. So then we would have the x actually instead of 1 over x, right? Which makes things a lot easier, right? So 1 over x is basically x, right? And you can input the 0 now into the x and you get 0. But keep in mind that this is the limit as x approaches 0 from the right of ln of y. So to find the limit as x approaches 0 from the right of the y, you have to raise e to ln of y, right? Because that's the equivalent of having y. And then guess what? We already know what the limit as x approaches 0 from the right is of ln y. That was 0, right? So we just plug it in, e to the 0, and we get 1. Okay, that's your limit value. Thank you so much for watching. I hope these tutorials were useful for you to in understanding how to use the Hopital's rule, when to use it and when not to use it. Okay, please subscribe to my channel, and I'll see you in my next video. We're going to talk about improper integrals. Thank you.